We're in the final stretch of Domain 3, and this is where everything comes together. How do you select the right controls for AI specific risks? How do you monitor those controls continuously? And here's the twist: AI isn't just what you're protecting, it's also a tool in your security arsenal. So, how do you govern AI powered security tools without introducing new risks in the process? This video answers all of that. Let's close out Domain 3 strong. The foundational principle for control selection is simple but easy to forget. Controls must be driven by risk, not by compliance checklists. Preventive controls are the first line. Access controls, encryption, input validation. They stop the bad thing from happening. Detective controls catch it when it does happen. Anomaly detection, output monitoring, audit log review. And compensating controls fill the gap when a primary control isn't feasible. Human oversight compensates for an unexplainable black box AI system in a high-risk context. The exam will present scenarios where a control is being selected, and the right answer is always tied back to the risk rating. If the risk assessment hasn't been done yet, that's the first step, not control selection. Controls without risk assessment are just guesses dressed up as governance. Let me walk through the technical controls the exam tests most frequently. Role-based access control and privileged access management are essential for AI environments. Who can access which model, which dataset, which API, and with what level of privilege? Encryption at rest and in transit protects training data, model weights, and API traffic from interception and unauthorized access. Key management means rotating model API keys regularly and never embedding secrets in code. Secrets should live in a dedicated vault solution. And network segmentation means training environments are isolated from production inference environments. If a training environment is compromised, the attacker shouldn't be able to pivot to the production model. These controls aren't AI unique, but they need to be applied explicitly to AI components, which many organizations haven't done. AI is now being used as a security tool, and this creates both opportunities and new risks. AI-powered SIM and SOR platforms detect threats faster, correlate events across more data sources, and automate responses at machine speed. UEBA, User and Entity Behavior Analytics, uses AI to build behavioral baselines and flag anomalies that might indicate insider threats. AI-driven threat hunting proactively surfaces unknown attack patterns without waiting for an alert to trigger. And predictive vulnerability prioritization uses AI to rank which patches are most likely to be exploited, helping security teams focus their limited resources. These are genuine improvements. But here's the flip side. Every AI-powered security tool is itself an AI system that carries the risks we've been discussing throughout this course. Bias in detection, lack of explainability, and adversarial manipulation of the detection model itself are all real concerns that the exam expects you to recognize. You must apply the same governance rigor to AI security tools that you apply to any other AI system in the organization. Before deploying an AI-powered SIM or UEBA solution, validate it, test it against your environment, understand how it generates alerts, and assess whether it introduces new risks. Bias in security AI tools is a genuine problem. A biased anomaly detection model might generate false positives disproportionately for certain user groups, wasting investigation resources and creating fairness concerns. Transparency is required. You need to understand, at least at a high level, how the tool generates its scores and alerts. If you can't explain a security decision to a risk committee, you can't justify the control. And document your tool selection rationale, testing results, and ongoing review cycle the same way you would for any other control. ISACA's preferred approach to control monitoring is continuous, not periodic, not annual, not at audit time only. For AI systems, this is especially critical because model behavior can drift, data quality can degrade, and new threats can emerge between quarterly review cycles. Automated control monitoring surfaces issues in near real time. Security dashboards display KPIs, detection time, coverage rate, response SLA, so the security team has situational awareness without waiting for a report to be generated. Control self-assessment validates both the design and the operation of controls, not just whether the control exists, but whether it's working as intended. And evidence collection should be continuous, not a scramble that happens in the week before an audit. Let me give you a concrete set of KPIs and KRIs for AI security controls, because the exam tests your ability to distinguish between them. KPIs measure performance, the percentage of AI models that have completed a security assessment, mean time to detect an AI security incident, percentage of controls passing automated testing, and incident resolution time. KRIs signal emerging risk, model drift frequency, failed access attempts on AI APIs, data anomaly detection rates, shadow AI instances detected in a given period, and third-party security score degradation. The key distinction: KPIs look backward, they tell you how you've performed. KRIs look forward, they tell you where risk is building. A good AI security dashboard has both. A risk-aware AI security manager watches the KRIs as closely as the KPIs, because the KRIs are where the next incident is announced before it happens. Board-level reporting is a skill in itself, and the exam tests it as a governance competency. Technical KPIs need to be translated into business risk language. Model drift rate means nothing to a board director. 3 of our high-risk AI systems are producing outputs that are drifting from their validated baselines, and without intervention, we estimate a 40% probability of a compliance breach within the next quarter. That's board language. Risk-adjusted metrics show the residual risk level after controls are applied versus the organization's stated risk appetite. Trend reporting answers the question the board actually cares about. Are things getting better or worse quarter over quarter? And investment decisions about the AI security program should be grounded in the control gaps and risk exposure you're presenting, so the business case is built into the reporting. Over time, control environments become cluttered. Periodic review should identify controls that are overlapping, redundant, or simply ineffective and retire them. Gap analysis compares your current control environment against your control framework and risk register. Where are the gaps? Gap remediation is prioritized by risk rating. You don't fix a low-risk gap before a high-risk one just because the low-risk fix is easier. And control changes, adding, modifying, or retiring controls require change management approval and documentation. Controls don't change quietly. Every change should be tracked, approved, and evidenced. The exam will test gap remediation scenarios where the correct action is to prioritize by risk, not by effort or convenience. AI security doesn't exist in isolation. It has to be woven into your existing information security program. That means explicitly mapping AI controls to your existing control libraries: ISO 27001 Annex A, NIS, TCSF. It means ensuring that your ISMS boundary explicitly includes AI systems so that AI isn't accidentally out of scope for your security management system. It means extending identity governance to model access and API access. Your IAM program needs to cover AI the same way it covers applications and infrastructure. And your cloud, application, and data security programs all need to be updated to explicitly cover AI. The exam tests integration thinking, not just what control applies to AI, but how does AI security integrate with the broader security ecosystem that already exists in the organization. That's the mature, program-level perspective ISACA is certifying you to take. Let me close Domain 3 with the exam tips that matter most. When a question asks, first step in implementing controls, the answer is risk assessment. You need to know what controls are needed before you select them. KP is versus KR is. KP is measure backward performance. KR is signal forward risk. This distinction appears frequently. For AI tool governance questions, the correct answer always includes validation, bias testing, and transparency. Apply those three to any AI security tool scenario. And continuous monitoring is always preferred over periodic review in ISACA's framework. If the question gives you both options and you're unsure, choose continuous. That's the direction the entire governance philosophy points.